So good morning guys and welcome to the software engineering course in the University of Albany. Um, I'm sure you guys will be learning a lot during the semester. But to begin with, we're going to get started with web application development, right? So we have our term project, and as the semester progresses, things will get a little bit more fast. But the first assignment and the first initial setup is going to be really, slow paced, so that everybody, including the undergraduates and the graduate course, because this presentation is shared between both classes. So about this first one, we're going to look at how web applications are developed, how they work. We're going to create a new machine in the cloud, and we're going to write our code to host this web application so that whatever you do will be accessible on the internet. To break it down, we're going to look at three different things in today's presentation. The first one is theory of web communication, right? So how everything works overall. Then moving on, we are going to look at how the cloud works and how you can use cloud to create a new machine. And the third point is going to be about developing a web application. So we'll be using Spring Boot to create your application. Of course, you can use Express.js or anything that you want. But for the course, we are limiting this semester for Spring Boot and Express.js. All right. So guys, to talk about our first topic about how does web communication work, please join me and welcome the subject expert in the matter. She's Sadie. All right. She's a well-published author, a subject expert, and she's going to be a chief guest today. All right. So I think she needs to leave. Yes, madam. I think so she says she has better things in life to do, right? Like to sleep, I guess. So I'll be talking about a few things about the URL, your internet addresses, your ports, communication protocols, displaying multimedia rich pages, and so forth. All right. So the first thing I'm going to talk about is what is a URL on the internet. Did you have some opinions, ma'am Adam? No? Okay, let me see something. Oh, nothing so far? You think I'm boring you out? Okay, great. Thank you so much. I think I'll continue from here. Thank you, madam. Okay, guys, so just talking about URL, right? Everything on the internet is accessible through URL. All right. In this case, this is a good example of what a URL looks like. The first part is a protocol that indicates what the server and the client are. So what the client actually intends to talk in the protocol of. So there are two of them which are majorly used in the web that you see. That is HTTP, that is Hypertext Transfer Protocol, and HTTPS, that is HTTP, but it's secure, right? So they have a lot of cryptographic stuff going on, like you exchange certificates and everything. Okay, so it's just a way that, so it's just saying that, okay, here's the thing, right? So imagine I come to you and I want to talk to you. How would I know what language to talk on, right? That is your protocol. You have multiple of them, right? So you have WebSockets, you have to go on. You can always go on these protocols. In this case, most of the web applications, they communicate on HTTP or HTTPS. The second part of the URL is called a domain, right? So that is what you have here. The domain uniquely identifies a server or a resource, right? So let's just say you have a machine, for example, to serve, I don't know, Google. In that case, google.com is called the domain name. All right. So every unique service has its own domain name. After that, after you see a /, and that's called your path. Now a path is like asking, so you go to a house. Now a house is your domain, and then you want to say, hey, I want to access, let's just say the back door or the front door, right? Or if you're a creep, the window. Okay. So it's essentially what you are asking the server for. All right. The next part is the query string. That is what you're kind of communicating. What is your intent, or you're trying to give more information. So you knock on the door. That is your path. So it's essentially like this, right? So you first of all you say, hey, I'm going to talk in English. That is your protocol. Then you go to the domain. That is your house. So you go to a house. You go to the path. That is like the front door or the back door. I would assume the front door, and then after that you say, hey, my name is this and I've come here for this information. All right. So that is what your query string is. A query string provides information from the client side to the server side. And the last part is your fragment. So that is essentially an indication for the server that hey, this is the part of the entire response that I'm mostly interested in. All right. So moving on. The next part is, hold on. So let me just go back again. So that is what a URL is. Now an internet address. Now when you say the protocol is HTTPS, you're assuming your address is 443. Okay. The when you say HTTP, it is port 80. When you say SSH, it's port 22. It is essentially like saying, okay, hey, you have these, you have this server, right? You have this house. You're essentially saying what are the available ports this house has for communication. All right. So you could have the ports are essentially like outlets. So you have electricity outlet, you have a water outlet and stuff like that, right? So that is what a port is. After that, we did talk about communication protocols. That is a standard of how things will communicate, right? So you have SPDY, the new one HTTP3 standards are coming in. So it is essentially how to communicate between the server and the client. The last one is about displaying rich multimedia pages, right? So imagine you have, let's just say, a video. How do you think the client is going to display that video? So your server has it, but just giving it away is not enough. You want him to say that, hey, where do you put it? How do you put it? That is why the browser, right? So we have come across a standard between the server and the browser. That is the HTTP, the standard, right? That's the hypertext transfer protocol and the markup. So that we use the markup. So like to say that this is the segment. So let's say this is an object. It has to be shown at this part of the web page. Okay. So to give you that information, or to say, so let's just say, hey, I want to place the name in the middle and it has to be bold. In that case, we would be having we would be learning about Bootstrap and CSS and HTML in general. Alright, so I assume everybody should know HTML when you're taking this course, but CSS and Bootstrap will kind of look along as we go ahead. Okay, so for the next one, let me just go ahead. So that is what essentially web communication is, right? So what you have is like a server and a client. All right, and the server talks to the client. The client talks to the server, right? The server is always available for receiving connections. Okay, and so like for example, you have this server over here, right? So you have a server somewhere. Now a server could be any machine, right? So it can be anything. So like for example, you go to a restaurant, your server is a paid server, but you're at your house. Maybe your friend cooks for you and he brings you the food. That could be your server. A server is anything that serves, right? And then you have a client, and they just communicate over a communication network. Okay, and what we do have is, so what we as a web, that is how essentially communication works. Okay, we all know this. The important part is to understand how they communicate, right? So in this case, we know that this one. So that we talk about URLs, like what to ask for and how they are asked. The addresses, that is a unique address for every machine that is on the network. So always remember this address, right? So we know that it is difficult to remember numbers. Every machine on the internet has a unique address, right? It may be IPv6 or IPv4, the different communication standards or whatever, right? So what you have is something called as a DNS. A DNS essentially converts your name to an IP address. So what you have is, let's just say you say, imagine, right? So my server is at 127.111.12.20. That's my address. Now what happens is it's difficult to remember this as a human. So what you do is you just say, hey, when I say google.com, change it to this, right? So there is an entire network system called as the DNS service and all those things that does this for you. But this happens without you knowing it, and so that's how you convert like a name to a number, right? So that is how web communication works. And then once the client knows the address, then the client can talk to this server at this address, and then we go on from there, right? Then we negotiate the URL. So in the URL, we're kind of saying it as a negotiation or as a contract, right? That hey, I want to talk in this language, and all those things. So guys, one thing to remember is every port is kind of like assumed to have a particular, so like every protocol kind of has a designated port to it. Now you can always change it, but these are some assumptions that are always done, right? So when you communicate over HTTP, it's port 80. You communicate over HTTPS, it's port 443. You communicate over SSH, it's port number 22, and so on and so forth, right? So you have all of these kind of ports. Okay, so let's look at the next part. Is about creating a machine in the cloud. All right, so for that we are going to use EC2, that is your Amazon Web Services. All right, so here's the thing. Again, as I mentioned, what is a server? An object that serves content. A machine in the cloud or your laptop. Remember, anything can be a server. Like I mentioned, right? Your laptop could be a server. A machine in the cloud could be a server. Anything can be a server. Now, what are the characteristics of a server? The first one is it has to be always available. All right. So a server is something who you assume it's always there for you. So whenever you talk to a server, it has to be there. Second, it is stable. So whenever you contact a machine that is acting as a server, it is not crashing all the time. Okay. The third one is accessible over a network. That implies it is accessible to somebody who is not a server. Otherwise, what's the point of a server to have a lonely server, right? So it's not going to be lonely forever. Well, never mind. Right? So this one, so the server needs somebody to serve for, and that is why a server has to be on the network. All right, and it has to be scalable too. So let's just say you imagine there are like many people coming. In that case, you want to ensure your server doesn't just crash. All right, it has to be scalable over the internet, right? So it has, let's just say your number of requests comes, so you kind of have to scale over it. So like, okay, so an application works for 2 requests, but let's say 200 come, you cannot say, hey, it's I just died, right? And that is the need of a server. Is like every application. So essentially, you want to have a service available for a client anytime you want. That is what a need of a server is, right? So a cloud computing. So why to use cloud? So if you remember the server characteristics, what were they? Availability, scalability, accessibility, and I think that's pretty much it, right? So similar things. So the reason for using cloud is that you can essentially have the service-oriented architecture. So you can spawn a new machine whenever you want. So, but let's just say you are using a laptop as a server. What would happen is, to add up a new server to the machine, you have to already buy a new laptop, put it on the network, ensure it has a good power supply, and it's always running and everything, right? What the cloud gives you the ability that, hey, you have a data center which is managed by professionals, and you can just go ahead, request a resource, and get it at the same time, immediately. Second is there are no upfront costs. So imagine you're a new startup, or you have a new idea. You don't have to waste millions of dollars in setting up new machines, creating a new server, and all those things, right? The third part is about infinite scaling, virtually infinite scaling. Whenever let's say you become more popular, you can always just ask for a new machine, or it can, okay, if you are using these services properly, or the way they are advertised to be, then you don't even need to ask for machines. You can just have your code and it runs on the machines. You don't have to, you don't care. Right? And the third is availability guarantees. So let's just say you do have a machine, you have a computer, you attach it to a network. What happens when the power supply fails, right? What happens when the electricity goes down due to a thunderstorm nearby, right? So a cloud computing essentially gives you the peace of mind that, hey, whenever you need it, it's going to be there. There won't be a time where a service is not available. All right. So most of the data centers, they have backup power supplies, backup power plants, right? So one in our university, it also has power from 2 different power generators, I would say, like hydroelectricity and something coal. I don't know much, but they usually, all good power data centers have redundant power supply lines, water lines. So if there's anything, you can always like move machines from here to there, and your services are not affected, right? So what is AWS? AWS is Amazon Web Services, is essentially a provider of a cloud computing infrastructure, right? So what it allows you to do is that it's a collection of services that you can access anytime you want. One of the service that AWS provides is called EC2, that is Elastic Compute Cloud. What this allows you to do is, hey, you want a virtual machine, you get a virtual machine. It essentially gives you a machine that is hosted in one of the data centers for a price, and you're billed by the time you use it. Okay. The second service is that we're going to look at during this semester is S3, and a simple storage service. It allows you to, again, as the name suggests, simple storage things. Let's just say you have a photograph and you want to store the photograph somewhere, right? It has to be accessible over the internet. What you do, you upload it over there, you get a URI, and then you go on from there. Okay. And there are some other services it provides, so like databases, lambda functions, and it's a big consortium of services that you can get. All right. And these are industry leading things we're talking about, right? So you can go with Azure, you can go with Google Cloud. They all have a similar approach towards things. So you could also so like there are different, if you go to the cloud computing jargons, they have like IA, infrastructure as a service, compute as a so like, and so essentially there's a lot of abstraction going on. So an EC2, you're given a complete machine by itself. All right. In S3, the machines are managed by Amazon, and you're given an API to just insert objects and get objects. Okay. Moving on, so let's start by creating your first machine in the cloud. All right. So AWS allows you to have 750 hours of free time running. Yeah, for one machine, right? So let's just say you have one machine running for 750 hours. That's free for you. But remember the time, so you're billed by the hour. So let's just say you have two virtual machines, okay? And so like essentially every hour that passes, you are using 2 hours of compute. Do you get it? It is essentially like, when you have 10 machines running on your account, every time that passes, that is every 1 hour, you're billed for 10 hours of compute. Okay. Let's just say you have one machine running for an entire month, right? So how many hours do you have in a month? Okay. How many hours do you have in a month? I'm going to say, let's just say you have 31 days in a month, and you have 24 hours a day. That is 744 hours. Like, so in the maximum you would have to be 744 hours on the and the billing, so it would be free, right? So this is for the initial year that you sign up and everything. So that's it. The second thing is every machine gets an address. Whenever you create a new machine here, you get an address that is accessible on the internet. Okay. So let's see how we can create a new machine. For that, you have to sign up for AWS. I am assuming everyone has done it so far. Now, after you sign up, you'll be. Let me just go to. Okay, let me just log out first. So you go to aws.amazon.com. You click on sign in to the console, the orange button on top, right? You go down. You enter your email address. Now in this case, I'm going to add my email address, and there we go. You click on next, and then you add your password, right? There you go. Next. Okay. Now when you log in, you should see something like this: an AWS Management Console, right? Here I'm going to search for EC2. There we go. Let's say virtual servers in the cloud. And when you click on that, you should be able to go to like the running instances. It kind of gives you a snapshot of what your resources are currently running. Always ensure you select the right data center over here. Okay, so let's just say you select Ohio in this case, right? So I have 0 machines running on Ohio. So students are like, oh, I have 0 machines running, then why am I getting billed? Because you might have a different machine running in a different data center. So like I mentioned, Amazon has so many data centers, and you're essentially creating a machine in that data center. So in this case, I'm going to use North Virginia because it is closest to the place I stay right now. So what you're going to do here is just go to the scroll down, see this launch instance, just click on that, and I'm going to click on the launch instance button. It asks you a couple of questions. Use the Ubuntu server here. I'm going to select that, and it's going to ask you, see, it gives you free tier eligible, right? So you can say it's free for the first 12 months, 70 hours of compute. So I'm going to select review and launch, go down and just click on launch. Then it's going to ask you for a way to communicate, right? So and ask you for so like how would you authenticate yourself. So imagine you have a machine there, right? How do you make sure that anybody, only the right people can log in, that is you can log in. In this case, I'm going to create a new key pair. I'm going to give it a name. Let's just say fall 20 lab. All right, and I say download a key pair. Now here what it does is it creates a PEM file. A PEM file is a combination of public and private keys, right? So all the cryptography mumbo jumbo happens, and once you have the key file, then you can like say, hey, I have the key to your lock, right? Allow me the entry. You click on launch instance, it's going to initiate the launch, and that's it. Now to go back to your home screen, you can just go to the services on top and click on EC2. Alright, when I go to running instances, we can see that I have one instance running, that is my original instance. I had it running, which I'm not going to change. But you see in the bottom, the second one we just created, right? It is still in the pending state. That means that, oh, it's in a running state now. So this has been created on the internet, and it can be accessed using this IP address. Alright, and it also has a public DNS address that I may mention. So it is a name, like a character name which you can remember. Now in this case it's a very big name, so you cannot remember it, but it's a name that you see this is the domain name for this machine. Alright, so that's so what we did is we essentially just created a new machine here. That's all. Voila, you have a machine in cloud. It's running in a data center in North Virginia. It has this public address, and that's it. All right, so moving on, we're going to see about installing software on this machine. Now okay, you have it running there right now. What do you want to do with it? The one thing you might want to do it is, hey, install something on it. In that case, I'm going to log into this this machine. All right, so for that, just a sec. Okay, so what we're going to do now is how do you communicate with this machine, right? So the protocol we are going to use is called SSH, that is a secure shell protocol that allows me to communicate with a machine on the internet using a protocol, right? So what I'm going to do now is, remember we downloaded a key file. Okay, so I'm going to just use that key file and create something. So this is, I have my machine in here, right? I'm just going to be like hey, so let's do it, right? So I'm going to say SSH. That's the command that I'm using, and this is my address of the machine. So I'm going to copy this address. I'm going to SSH-I. I'm going to give it the key that I have. All right, because it's going to have a problem if I don't give it a key, because you remember, not everybody should be able to log into this machine. I'm the owner. I should be able to log in. All right. So in your iPhone, you have the Face ID. All right, but how do you know that how do you know the identity of an individual if you don't have a physical access to the machine? Is you using this PEM file, and I'm going to say Ubuntu @ the address of my machine. You do enter, it's going to ask yes, and oh sorry, yes, not yes, yep, there you go guys, right? So we are inside. Wonderful, isn't it? So now what I'm going to do now, oh wait, hold on, it has a problem. It says unprotected private file. Oh yeah, so good point. So what happens is when you're trying to SSH into something, they don't want you to have a file that is very open for anybody to handle. So the key has to be locked down. For that case, you're just gonna do chmod. Okay, so all these instructions are, by the way, right over here. If you kind of like go up a little bit, hold on, disconnect. All right, up. So you can, by the way, you can also use the online version that they have for the connection, but in this case we are not using that. Say SSH client. So here you can see that, see this, all the things that are here. See this chmod and all those things. I'm going to do that. I'm going to say chmod 400, and it's in my downloads folder. Oh shoot, never mind. Okay, I need to fix that later. But don't do this. Don't chmod 400 your entire downloads folder. In this case, I'm going to do chmod this, and that's it. So if it doesn't give you that, sudo. That's because I just changed. This was the wrong command, guys, the earlier one. So yeah, never mind, I'll take care of it later. So there we have it, right? So now when I do the same command now, if I do ssh-i, all those things, says permission denied. Very interesting. Okay, so like I mentioned, I kind of messed up my downloads folder earlier with that command. So, and make sure you write your commands properly. I kind of messed it up there. So I just changed the permission back to 777, and again we just do the ensure that you do 400 only for that file. Okay, it's done now. Now I'm going to do SSH and the -i, the name of a file. I'm going to say enter. All right, there we have it. Now we are inside the machine. So you remember this? It says welcome to Ubuntu 18.04. All right, there we are. Now how would you install things, right? So let me just add another window capture. All right, so let's look at, so you do have a machine. You can log into the machine, and you're all set, right? So in this case, what I'm going to do now is, now we're going to install this software, that's your Nginx and Java 11 on this machine. All right, so let's go back to this view, and what we can do now is, let's just say sudo apt update. So I'll be trying to, I'll post these commands on the blackboard as a supplementary material. All right, so it's just updating. So essentially what you're doing is, you have like an app store for Android, an app store for your iOS device, and a Play Store for Android, right? Similarly, you have something called as an apt. It's an apt repository. You're saying, hey, update your packages, right? I'm going to say sudo. That is, you're saying sudo is like super user do. So it is like an administrator privilege in Linux, right? On every machine, like you have to have who can install a software, right? In this case, only the administrator can install a software. That is why what you do is you say sudo. That means as a super user you do something. Okay, then the next command is apt. That is the name of your app store. I'm saying, hey, sudo apt install. That is the name of name of an attribute that the command apt takes, right? So essentially, you see what I'm doing is, I'm essentially just writing out what is in my mind in a way, right? So it's sudo, hey, as an administrator, go to the app store and do what? And hey, install Nginx. All right, and it's going to ask me, hey, it is going to need so much space. Do you allow? I'm going to say yes. Okay, that's all. That's how you install software on any on any Linux machine, on any Ubuntu machine. Just go sudo, right? Okay, I want to install something else. I want to install a different app. Sudo apt install git. All right, boom, it's already installed, so that we don't need that. Okay, so now for installing Java, it's a little bit more involved, because there are so many versions of Java. Which one to install is a problem. You do something. You go to the internet and be like, install Java 11 Ubuntu. All right. So when you go down there, we should have it. So DigitalOcean is a really good resource that I like to use. They have very good articles. And if you just go down there, hold on a sec. There we go. You have, so like the default version should be there. Simple, right? So again, how to install? Sudo apt install. Sudo apt install default JDK. Enter. There you go. It's gonna ask me, and I say yes, and it's gonna keep on downloading things. Sorry. I'm going to install JDK and the Java runtime, the Java runtime machine, right? The JVM, sorry. The entire Java runtime. It's going to install the entire Java runtime, and that's how you get it. That's how you install stuff. So our objective was, it's progressing. I'm going to go back here. So our objective was to installing software on the machine. So we did install Nginx, we did install Git, it was already there. Sorry. Okay, again, not this one again. I have to find where it is. Oops, okay, there I am. So you have to install these 3 softwares because we are going to use Spring Boot. Alright. So now the next task is to make it accessible on the internet. Hey, so you have installed stuff. How do you make sure that this machine is accessible on the internet? Like I mentioned, even though you have the address, you need to open up the ports, right? So you have these ports that you want to kind of expose to the internet, right? So like everybody on the internet can access your machine. How do you kind of say that? You might have a machine who you want only for a specific network. So in this case, I'm going to open it for everyone. So what people do is, it's a good practice that some people do is like, okay, you have 10 different virtual machines, right? But only one of them is accessible over the internet. And then they kind of like they do something we call load balancing. So the rest of the machines are only accessible over an internal network. And so one machine kind of forwards the request. The only job that machine has is to forward requests. All right, that's it. And the other machines do the compute things. So how do we make it accessible on the internet? Very, very simple. Let's just look at it, right? So you have, I'm going to go to my Amazon console. There we go. I'm going to my instances. That is my running instance. If you scroll down here, right, you can see in my security, right? Go to the security position there. The security groups. I'm going to click on, right? So when I click on this, I can see that these are my inbound rules. So all the network activity is bound by a certain amount of rules, right? So we see that my inbound connections only port 22 is allowed. I'm going to edit these rules, add a new rule. I'm going to give it like HTTP, right? There we go. Now HTTP, like I mentioned, is assumed to be 880. So it is assumed to be 80. I'm going to say anywhere. So anywhere from the internet you can access it. I'm going to save this rule, right? There we go. You are started. So you essentially just allowed the thing on the internet. So your machine is now accessible on the internet. Okay, there we go. That's how you open a firewall. Now the next step is developing a first application. But before we go into that, I want you to just have a proof that, hey, what do you mean by accessible on the internet? So let's just go to my machine here. Hold on. Let me just switch the view. There we go. So it says it's done. All right. So we have everything running. If I just say Nginx, it should be there. It's fine. No problem. No worry, right? So now what we're going to do now is, if I remember, every instance has an address. All right. So I'm going back to my EC2 machines, my running instances. I'm going to go to my networking. I'm going to copy its address. I'm going to open it over here. Okay, I'm going to copy this and let's just open it in a tab. Welcome to Nginx. Because you install the Nginx package, what is Nginx? So an Nginx is an application that allows you to serve content. Okay, so you have a static content that you want to serve, or you want to have an application. So like let's just say you have. So what happens is, guys, one sec. There we go. So what happens is, in production environments, what you have is, so let's just say you have this internet, right? So you have this entire internet, right? And what you want to do here is, you essentially have an application. This is your server. It's somewhere on the internet, right? So in your server, you kind of install the application called as, this is Nginx. Okay, and this forms like the first point of contact between you and the client. Okay, so in this case, what happens is, okay, so we are communicating over port 80. So in Nginx listens on port 80. Okay, so like we mentioned, like every port has a, okay, so every port has a specific intent, right? In this case, Nginx is going to listen on that port. Now, after that, Nginx can do whatever it likes. What we usually use Nginx is to kind of act as a reverse proxy. So you have this as Nginx is running, right? And then you have your Java application running on the same machine, right? And it is listening onto some port 8080. All right, but remember, you only open the port number 80 in firewall. Now you can always open this port so that your application is accessible on the internet directly. But just to, of course, we don't need this for this assignment or this course, but it is a good practice to have such a setup, and then these two kind of just talk to each other internally on port 8080. Right, that is why we use Nginx. Nginx is also used for serving static content. In this case, it's just a HTML file that Nginx is serving, right? So what Nginx does is it listens on port 80, and whatever request you get is going to search for that file, okay, and it's going to serve it. Okay, that's all it does. So in this case, let me just show you where the file is. If I go to this, if I go to my terminal, and hold on a sec, if I go to cd var www html and public, right, you see we have this HTML file over here. That is the first thing that is always, there we go. So if I just say welcome to Nginx, and if I change it to, let's just say, welcome to software engineering. So this is an HTML file. It's a normal HTML file, right? So welcome to, I save it. Okay, you need, okay, super for this one. Okay, there we go. Now if I refresh this page, there you go, welcome to software engineering, right? So very simple. So what Nginx does is it kind of tries to find the file. That is, since you are accessing, remember, this is my URL, right? That is my, in the URL, it is trying to access the /. So whenever you don't see anything, my path is blank, right? So when it is blank, the default page it tries to serve is called index.html, and that's why it is serving this page. All right, so that is what you have. Hey, you have your everything on the internet right now. Okay, it's running on the internet, you can access it, and there we go. Now after that, okay, there we go. Now I'm going to go for the next slide, that is developing a Facebook application. So that is, first of all, now we are all clear about having Nginx, how it is serving your page on the internet. Anybody in the world can go to this address and they would find this. All right. So now the next topic is about making it accessible on, sorry. The next topic is about developing your first web application.